everybody, and a warm welcome to our 5th episode of Superpowers ReLoaded. The topic for today is digital fitness, algorithmic thinking, and how it impacts your life. Together with Future Academy, we created this event series for all founders, innovators, and people who want to develop their personal skills. Don't worry if you missed one of our first sessions. You can see them on our video learning platform on our website. I'm Therese, I'm the event and comms manager of Wayra. Why are superpowers so important to us? We're living it now in our daily lives and have to find the best way to shape the new normal and adapt it to our needs. Our main goal at Wayra is to connect startups with our mother company, Telefonica. Why? We do that with paid pilot projects for startups over 4 months. The goal is to win Telefonica as a client for the startups and sign a commercial contract. Our main scouting areas are, for example, IoT, 5G, and many more, which you can find on our website, wayra.de. Besides that, we have a big community of over 70 members sitting with us in our lovely office in the heart of Munich. Especially for growing companies like startups, our superpowers are essential for their success. However, we all work in teams on a daily basis, so we believe it's a superpower we all should have. I'm super happy to have Markus, CEO and co-founder of Future Academy X, and Max from Galactify here with me today. Maybe you can just say hi.
Hi.
Hello.
Cool. They are part of our Wayra community. Markus and his team developed the framework for the core competencies essential for the 21st century. While the two will guide you through today's session, I will be in the back supporting with a smooth run-through. So some heads up before we start. If you have any technical issues, please feel free to contact me directly in the chat. We prepared challenging and insightful content for you. We all know the feeling of getting distracted, so we suppose you close Outlook, put away your phone, close Slack and WhatsApp and whatever you have opened in the meantime. Regarding questions, feel free to post them in our chat. We will take the time to answer them afterwards. So that's it from my side. Over to you, Markus.
Actually, over to Max.
Oh, over to Max.
Okay. Yeah. Hello together. I'm Max. I'm the titular coder. I want to tell you something about algorithmic thinking today, and especially what it is from my point of view. So I also want to show you that algorithmic thinking is quite practical for everyday problems. And well, for me, algorithmic thinking is part of my job, and I don't know, and it's already like 20 years since I started coding. Already as a kid, I was super curious about computers. I'd like to sneak into the office room of my dad and go to his Commodore C64 computer. For him, I think it was super dull, but for me, it was mysteries and adventures. So what always hooked me was the idea that you can teach the computer to do something, well, actually anything. But what I found out pretty soon was that the computer is, well, very fast and smart, but actually speaks a different language. And if you don't tell him exactly what he needs to do, he will do nothing. So yeah, this algorithmic thinking is a lot about telling a computer what to do, but also telling other people what to do, and like explaining tasks to others. So this is very basic for a lot of problem solving stuff. So yeah, this is my little introduction. So maybe another addition. I'm a software architect and developer for now 9 years. I worked in e-commerce, automotive, and software as a service. So I founded 2 tech startups. The last one, current one, Galactify, and we want people to better understand complex problems with an intuitive and visual user interface, which also kind of is relevant for today. So yeah, that's my part. I'm looking forward to exploring the world of algorithmic thinking with you. And now I give over to Markus.
Thank you, Max. Very good. Okay, so welcome also from my side. Yes, we're gonna look at how to think and reason like a programmer today. Very special topic. Before we dive into this, Therese already alluded to it. I'm the co-founder of the Future Academy X. And essentially, our mission is really to bring all those competencies that you probably never learned at school or at university to companies and organizations. And in this spirit, what we've done is basically just put together a framework which is based on the 4 superpowers of the 21st century. And so we've already covered 3 of those superpowers in previous webinars. Today is really entirely focused on digital fitness and algorithmic thinking more specifically. Now, I need to tell you that there's some personal invest I've got in this topic. About 12 months ago, I decided to go on a rather unusual journey. I've decided to do a bachelor's in artificial intelligence. So you might ask, why unusual? Well, number 1, I've already got a degree. Number 2, I'm not 20 anymore. And number 3, I'm coming from a very different background. What you see here is essentially the lecture hall of the University of Linz, which is where I'm studying. Obviously, everything is online these days, and we don't need to go to Linz anymore. But this is where I at least hung out at the beginning of the lecture. Now, I'm coming from very much a soft skill background. So I've done lots of sales and marketing. Within the Future Academy, we're doing lots of training and coaching. Relationships are obviously important, creative work, etc. And I've gone to something entirely different, which is an engineering degree ultimately, and learning all these subjects that I really knew nothing about before I started. So I cannot tell you how challenging this sometimes was for me. There were days when I wanted to grab my laptop and really throw it against the wall, because I was just struggling so much through some of these relatively complex problems. But there's also so much joy in this, because I'm starting to learn stuff and I'm discovering areas in my brain that I didn't even know existed before. And this has also been a little bit the perhaps inspiration to sort of, because what I noticed was that when I watched programmers like Max and I was intrigued how they actually approach real life problems and then trying to translate it into zeros and ones so that the computer can understand it. And this is really what this is about, and also how this could potentially apply to your life, even if you're not a programmer. Now, the agenda will be quite simple. We're briefly going to talk about why it matters. So why should you bother in the first place? Then Max is going to take you through, what does algorithmic thinking actually mean? What is it, and what are some of the building blocks? And then right at the end of this, we're going to have a quick session where you have the opportunity to think about how you could potentially apply this to your own life. Good. So why should we bother? Everybody in this country should learn to program a computer, because it teaches you how to think. Now, this is a relatively big statement, but what does it actually mean to think? Now, this might not be as trivial as you believe it is. And in order to deconstruct this a little bit, what I would like to do with you guys is a short quiz. And so what I'll ask you to do is actually write your answers into the chat. This is very quick. It's only going to be 3 questions, but you'll see in a minute why we're doing this quiz. So some of you have probably heard of trivia or pub quizzes. We don't have any pub. We also don't have any beer, but we're going to use this virtual environment to collect your answers. Don't worry too much about the answers themselves. This is not an intelligence test, by the way. This is really just, actually, in fact, what we want you to do is to answer as quickly as possible. Don't even think much about it. Just sort of your initial gut feel to the question, just answer it. Okay, I hope everybody is ready. Therese is going to watch it a little bit. Number 1. A racket and a ball together cost €1.10. The racket costs €1 more than the ball. How much is the ball? Over to you, very quickly. Again, don't think too much about it. Your intuitive first answer is what's important. Therese, have we already got some answers?
Yes, we do in the chat.
Okay, good. Can you read them out for me briefly?
Sure. So one is 5 cents, 0.1, 0.1, 1.05, 5
Okay.
cents.
Good. We don't need to all of them. I'll move on to the second question, and we're going to do the solution in a minute. Number 2, we've got 5 machines which need 5 minutes to produce 5 parts. What do you think? How long do 100 machines need for 100 parts? Again, your quickest, most intuitive answer, please. Don't think too much about it. And as you put them in the chat, Therese will read them out for us.
Yes, 525 minutes, 10,000, 500, 500.
Thank
5.
you. And now the last question. A carpet of water lilies floats in a lake. Every day its area doubles. If it takes 48 days for the water lily carpet to cover the entire lake, how long does it take to cover half of the lake? So 48 days to cover the entire lake. How long for it to take for half of the lake?
24, 47, 1 day, 47, 47, 47, 24, 24, 47, 24,
Good.
47.
Let's look at the answers then. So here you've got it. This was the racket and the ball. Ball cost 5 cents. The racket €1.05. So €1 more makes together €1.10. Quite simple, but we'll talk about why this is relevant and why you might not all have gotten it in the first instance. Here for the second question, it was the 5 machines that produce 5 parts in 5 minutes. Then 100 machines will also need 5 minutes for 100 parts. Maybe unexpected for some of you. And the final one was the lake, and I think a lot of you had 47. So this was exactly the right answer. Now, let's just look at this. Now, first of all, it's important to understand, and you might have noticed this, the brain intuitively wants to have an answer really, really quickly. And it might have something, or you might have something on your mind that you just intuitively wanted to put in the chat. Now, this is really important to understand because what we know from the brain is that, and this is an evolutionary thing that we should be aware of. What we know from the brain is that our brain is very expensive. In fact, our brain makes up about 2% of the total body mass, but it consumes about 20 to 25% of the total energy. So of course, you're trying to use it as little as possible. And in fact, evolution has found a way to make sure that it's going to minimize energy consumption. And how did it do it? Well, quite frankly, we don't just have one brain. In fact, we've got 2. And this is what we call system 1 and system 2. Now, system 1 is essentially your intuitive, your automatic response. So when you were initially putting an answer down without really thinking about it, this is typically your emotional brain or your automatic intuitive brain. But there's also another part of the brain, which is the neocortex, and that is a lot slower. It's very controlled, it's focused, and it's logical. And so in history, we've used system 1 a lot because it's also the survival system of our brain. And when you need to run from the lion who's chasing you, then that's the kind of brain you would be using. I'm sure you've heard about this before. But if you need to think about a really difficult problem, then you need to engage a different part of your brain. And so the reason, and this is basically all, behavioral neuroscientists and behavioral economists have proven that this is exactly the case. Now, here maybe this is a more descriptive terminology, if you like. Some people also refer to system 1 as the elephant and system 2 as the rider. Now, what's important here is that sometimes we're using the elephant when we really shouldn't. And so we're taking sometimes really stupid decisions, not because we're stupid per se, but we're just engaging the wrong part of our brain. And so you might all be able to think of some people who've talked before they actually thought about something and either delivered harm to other people or even to themselves. And this is what sometimes happens to us, right? So we sometimes just talk with our emotional brain, but sometimes not really good idea. Now, this is the main reason why we believe algorithmic thinking is really important, because it can help us to engage the rider as opposed to the elephant, and it will give us a framework to think stuff through. So before you go into this board meeting to discuss high-level strategies for 2021 with your investors, or before you maybe even engage your partner in a conflict discussion, it's always a good idea to start thinking stuff through. But also, one reason why it's important is because, as you all know, complexity is increasing. Like the amount of information that we as people have to digest, filter, and then make complex decisions is increasing. And so we need to make these decisions, but the emotional brain can't do them for us, at least not always, especially when it's long-term and important decisions we need to make. But there's another reason. I don't know who of you has seen or watched The Social Dilemma, which is a documentary which is currently on Netflix. And essentially the key message of this documentary is that social media and Facebook are turning us into robot addicts. So in other words, we constantly go back to our smartphones, to our laptops, in order to engage with social media to find out whether somebody liked our posts. And of course, what we know now, and I think they even talk about this in the movie, is that social media entirely talks to our emotional brain. And it's quite easy to make it addictive, because we know that every time you get a like, then you get a dopamine hit in your brain. And this makes you keep coming back and back over and over again. But the big question we should ask ourselves is, do we really want to do this? Or are there other ways, and are there other possibilities to actually engage the rider instead of the elephant? And this is important because whatever we put our attention on will grow stronger in our lives. So if you put a lot of attention on your emotional being only, and you sort of neglect the rider, then this is what's going to grow more, and you might be more addicted to social media as a result. The final piece before I hand over to Max is that we also know that coding and thinking like a programmer actually trains conscientiousness. And we also know that this is a highly important character trait that will help us to be more successful in life and in our profession. We also know that people who are conscientious are more organized, they're determined, and I think the most important piece is that they're able to postpone immediate gratification for the sake of long-term success. So I hope this has given you enough reasons to now go into the main part of our webinar, which Max will lead, and give you a bit more insights into how he thinks and what sort of methodologies and processes you can use in your own life. Thank you.
What is algorithmic thinking, actually? So thank you, Markus, for the introduction. So as we had before, algorithmic thinking is a lot about problem solving. And actually, in a way, I'm facing a problem right now of explaining you what algorithmic thinking is. So how can we approach this? So maybe let's break down this question. There are like two important words in this question, algorithm and thinking. So let's see if we can find good definitions for both of them. So algorithms are mostly associated with telling computers what to do, but it's not only about instructing computers, humans follow algorithms too. Actually, all of you are following algorithms on a daily basis, as we will see soon when I give some examples. So what are algorithms? They are simply a set of instructions that are followed step by step to do something useful or solve a problem. So algorithms are a set of instructions to solve a problem. Where was I? Yeah, this the part about thinking. I won't go into too much detail here because it's a big topic. Simply said, thinking is manipulating information, as when we form concepts, engage in problem solving, reasoning, and making decisions. It allows humans to make sense of the world they experience and to make predictions and to decide how to act on it. So make sense of the world and decide how to act on it. Now that we have our definitions for algorithm thinking, let's focus on what's important here. So first, for algorithm, of course, the instructions are critical. And as I said before, it's a lot about solving a problem. Where thinking makes sense and how to act stands out. So yeah, now that we shrunk the definitions to the crucial points, we can recombine them and well, actually, what we will do is we cut out decide how to act as it's already part of make sense and create instructions. So what's left is kind of a nice little definition of what algorithmic thinking is. It's a way of getting to a solution through the clear definition of the steps needed. So, for example, a good example you all followed before, an algorithm you followed before is cooking as a recipe. It's a finite list of instructions used to perform the task of cooking. So for example, if you were to follow the algorithm to create brownies from a box mix, you would follow the 3 to 5 steps process written on the back of the box. So yeah, now that algorithmic thinking is involved in part of creating the cookie recipe. So when we talk about algorithmic thinking, we say it's the part to come to this instructions we need for this algorithm. So in the case of cooking, to solve the problem cook, we actually need to make sense first. So understand how cooking works, choose the ingredients, check how to combine them, then find out what tastes good, and etc. So then after that, we can create instructions, which is a step-by-step guide of how to combine and process the ingredients. So now, hopefully, we got a better understanding of what algorithmic thinking is. Let's see how it works in practice. But before we continue, let's step back again and see what we actually did there. You remember my problem of explaining to you what algorithmic thinking is. So let's see, what did we do? We took this first question and decomposed it. We broke it down into smaller parts so that we can better analyze it. We tried to find meaning of those parts, kind of patterns. And after that, we focused on what's important. And yeah, and in the end, we got our nice definition of what algorithmic thinking is. So what we did here is actually following those steps we often find in algorithmic or computational thinking, decomposition, pattern recognition, abstraction, and the last part, the algorithm itself. These steps are tools to help us formulating a problem and expressing its solution, such that a human or computer can effectively carry it out. So let's take a look at each step in more detail. And you will notice that we do each of those steps more or less automatically or implicitly on a daily basis. So first is the step of decomposition. It's breaking down large complex problems into smaller ones and more manageable ones that can be solved. So for example, you do this every day almost automatically when breaking down the bigger task of making breakfast into smaller tasks like, I don't know, slicing bread or boiling water. Or another example, when we give someone directions to our house, we are decomposing the process of getting from one place to another by explaining the route step by step. Or when we plan to do a complex project, we divide things, the things to do into tasks and subtasks. So we do this more or less automatically, and it helps us to better understand the complexity of a problem. Next step, pattern recognition. It's noting similarities among problems and the ways they have been solved previously. So once you have decomposed a complex problem, it helps to look for similarities or patterns, and these patterns can help solve the larger problem more effectively. So AI people may know this, of course, and you see it on the screen. It's how pattern recognition works on images or photographs. Many people use face recognition photos when posting to social media, which is a form of pattern recognition the computer does. Another example, drivers look for patterns in traffic to decide whether to switch lanes, or investors look for patterns in stock prices to decide when to buy or sell. Next step is abstraction, and it's about identifying information that is irrelevant and focusing only on the information important to solving the problem. It helps us to form our idea of how to solve the problem. For example, say you want to identify all of the 50 states of the USA on a map. So you don't need a physical map you see on the left that shows rivers, lakes, mountains, etc. But you actually will need a political map, which is an abstraction of the physical map, which omits details like rivers and stuff like this, so you can really focus on the location of the states. Another example, when you tell the story of a movie to a friend, you don't describe every single detail, but give an abstract summary of the story. Or also when creating presentations for your manager or boss, you will focus only on the important aspects. And well, the last step, the algorithm, it's create a step-by-step plan of action. Those steps should be simple and scalable, and well, they should solve the problem, and in the best case, automatically. So for example, when a cook writes a recipe for a dish, he or she is creating an algorithm that others can follow to replicate the dish. Or when your friend writes down the instructions to get to her house, she is specifying a sequence of steps. Well, that is an algorithm for you to follow. So if you can tie shoelaces, make a cup of tea, get dressed, or prepare a meal, then you already know how to follow an algorithm. So now that we saw the theoretical part, let's try to create an algorithm ourselves. So here's a practice we will do together. So the goal is to instruct a robot to find a number in the telephone book, although he has never done this before. So the robot doesn't know what a book, page, or telephone number is, but actually he's pretty smart and does understand concepts, but only if you explain it to him very explicitly. So we will now divide you into groups of two. Therese will do this in Zoom. And one of you has to play the robot, and the other one has to play the instructor. And the instructor has to explain to the robot very explicitly in simple steps, well, how to find someone's telephone number in a telephone book. Is everyone back? I actually heard we lost people on the track, so now they were scared or they had to do something practical. So I'm super curious. Does one group like to present, or maybe you could do it differently? Could you write in the chat whether your robot did find the telephone number? I did in this practice when I did it with myself. I broke down this telephone book into the smaller parts. So actually, you have to explain the robot first. What is a telephone book? So it's a thing that consists of pages, and on each pages are lines, and the lines are then again separated into name and number. So of course, you could go more into detail, but actually, I think more abstraction doesn't make more sense. What's important here is name and number. We can find again, it's someone's name and someone's number. So this is a crucial part, name and number. It looks like this, one line, and actually here's the important thing to find in a telephone book. You need to find the name in the book. So you need to find the name on the page and actually get the number from the name on the specific line. So this is the breakdown of this main problem into smaller problems, kind of. So what you see, this decomposition thing is also something I did here. So maybe one more thing. Also, someone asked this in the group. You can point out to the robot too. The names are sorted alphabetically. So this is an example for pattern recognition. Obviously, there's a pattern in this book, and we sort this alphabetically. How can instructions really look like for this? So we make it as easy as possible. Like we pick up the phone book, open the first page after, of course, explaining to the robot what's a page. We find the name on the page by going through the lines and seeing if the name is on this page. If the name is on the page, we get the number from the name, like from the line, get the number. If the name is on the page, well, we get the number from the name. If we're on the last page and we haven't found the name yet, so we couldn't find the number, we repeat we go to the next page and repeat from step 3. So this would mean we go page by page through this book, and in the end, well, the robot will find the number for sure. Of course, it's a pretty tedious task, and it's a poor robot. So there's a better solution, actually. We don't need to check every personal phone book. Well, actually, there's a trick, and it got to do with our pattern. We recognized the alphabetic order of the book. So actually, we can do something we do ourselves, also again, more or less automatically. It's called divide and conquer. So now we do it a little bit differently. We pick up the phone book, we open it now to the middle of the phone book, and we've tried to find the name on this page. If the name is on this page, well, we get the number. Otherwise, well, if we didn't find it on the last page, we couldn't find the number. But what we do now is if we see, like alphabetically, okay, the name has to be on the left or on the right of the book, we open the book either to the left middle of the remaining part or to the middle of the right half of the book. And by this, we now always have the pages we have to look through. And this will lead to a solution much faster than going through page by page. Actually, in computational terms, this is called a logarithmic running function instead of a linear running function. And of course, goes to the solution much faster. So building an algorithm is not only about creating the algorithm, but also optimizing it. That's an important step. So I hope this helped shed a little bit light on how to develop algorithms and where the difficulties lay. Now this was already a pretty trivial problem, but we can see that it's quite complex, and it's also very tricky and tedious to write down explicitly step by step what to do, and especially when you explain stuff to computers. Unfortunately, that's what you have to do. So first, it gets complicated pretty fast. Second, this list of instructions looked pretty dull. So here are two things I encountered when I, in my work as a coder. Things I learned are pretty helpful. First, here's this principle of plan, play, learn. So we learn by doing. Like this part we talked before, it's mostly about creating algorithms on a theoretical level. But what's super important, and especially I think it's super important, actually the practical part, so playing with it. And then, of course, learning from experience. So it's also something you you will find in other disciplines like agile development, you have this build something fast, test it out, learn from the user feedback and iterate. It's also those 3 steps also in design thinking. You have this. So it's proven that the brain needs feedback loops to learn. And if you think about it, playing is a lot about solving problems. So it's way harder to solve a problem only theoretically, but you should test the solution practically and learn from it. I think that's super important. We can't go into much detail here. I wanted to do another practice, but we don't have the time for this. This is a nice page, scratch.mit.edu, where you can play like graphically with algorithms. You can put in visually with drag and drop code fragments, and this will make this little guy here move or talk or something like this. It's pretty fun and quite cool to check out programming basics. So a second takeaway, a picture says more than 1,000 words. So images are processed between 600 and 600 times faster than language. The human can process entire images that the eye sees for as little as 13 milliseconds. So visualization helps a lot of with understanding complex problems. So, for example, this is a fun diagram I found from Sheldon Cooper, how to meet new friends. So basically, you call them. If they are not at home, you leave a message. What you want to ask is, would you like to share a meal? If yes, friendship begins. If no, you ask them for a hot beverage. If yes, friendship begins. If no, you ask them for activities, and well, ask them a few times. And if they if you ask them more than 6 times, then you just choose the least objectionable interest. And if so, yeah, partake in the interest, and ta-da, friendship begins. So this diagram, what we saw, it's called activity diagram, and it's quite helpful. It's super easy, and it's a nice graphical representation of well, complex workflows or stepwise actions. It's good for describing situations and problems and relationships. So, and those are the basic elements. You start somewhere, have some action, have decisions, and go to the end. For example, well, are you hungry? Yes, then open the fridge, eat, and finish. Are you not hungry? Well, do something else and finish. So I think we don't have time. Markus, what would you say? I think
no, I think it's probably
yeah. Actually, I have to hurry. So I wanted to do another practice where we try to make a activity diagram for this phone book example. So this would be the solution. It's just as instructions we saw before, but now a little bit more practical, kind of. You get a better overview when you have it visually. So it's the same thing. Pick up the phone book, open to the middle. Yeah. I won't go into too much detail here because we don't have time left. And you will all get this presentation. So if you're interested, you can have a look at it. So to summarize, I want to tell you or to show you those 3 little tools or things you can do for to tackle a problem. If you encounter problems, first those steps we saw, this decomposition, pattern recognition, abstraction, especially, they are very helpful in tackling problems, complex problems. And there's this page called untools.co, which is a great collection of methods to help you solve problems, make decisions, and understand systems, kind of which fall into one of those categories. It's pretty cool. Then, of course, try to visualize stuff if you stand in front of a complex problem. draw it or use tools. You can use PowerPoint or other graphics tools, or maybe go to our starter page and look at galactify.com. And the last tool, learn by doing. And like if you, especially if you want to do something with the computer, play with it. Just try to get some practical hands on it. And as I mentioned, this if you want to start playing with algorithms and a little bit programming, use the Scratch thingy. It's pretty nice to play around with. So yeah, this was my part. Now I give back to Marcus. Thank you, guys.
Yes, thank you very much, Max. Good, guys. So we're almost at the end, and we're gonna actually cut down the 5 minutes into maybe 2 to 3 maximum. Therese, I think that should be possible. What we wanted to know from you, and if you could briefly, we're going to push you back into your breakout room. So you're going to meet somebody random in a moment, but again, it's only going to be 3 minutes. The question that you should briefly discuss is, can you apply this to your own life, number one? And how and where do you think this is actually relevant? Okay, so Therese is going to push you back into groups of 2, I believe. Guys, well, we're all back again. I can see. I know it wasn't an easy question to answer, but maybe if you could quickly write in the chat, was there anything revealing that you came out with? Anything where you thought, wow, this is really something I could potentially use in a business meeting, or we just discussed in project management? Is there anything specific you want to note down in the chat? If so, do so please now. Check assumptions. Does everybody understand tiny steps I'm aware of? Okay, yeah, very good. Importance of definition, yes. Yeah. This is really, both of them are really important points, because when you program, it's just incredible how much implicit, and I can say that because this is not my background originally, how many things are implicit to us, and we need, Max and I were talking about how you need to make the implicit explicit, because you just know stuff kind of by heart, but the computer doesn't. And so actually noting down and being very precise and specific really helps to sort of sharpen your thinking. And especially before you go into a meeting, I think that's a really good idea, because if somebody is a very detailed person and they're trying to challenge you on something, and if you've really broken it down, then you're a lot better prepared. Helps with cooking, very good, yeah. Cool. Yeah. Okay, guys, I think we are already over time. Thank you very much. So this was the first one, by the way. It was a little bit of a pilot and an experiment. I know. I hope you enjoyed it. We and Max, maybe you can say something as well, but I really enjoyed it. I thought it was cool how much you engaged, and I was in a couple of the interactive sessions, which was really fun. Max, anything else you want to add?
No, it was fun for me too. I really liked your answers after the robot example, and yeah, I hope it took something with you.
Cool. Therese, any last comments?
Yes, thanks a lot for participating, and Max and Marcus, thanks a lot for preparing the session. I think it was really, really interesting, and everybody could take something with them home to just to apply in their own personal life and maybe also professional life and work. So thanks a lot, and I hope to see you soon. So if you haven't done so, you can of course visit the website of the Future Academy or Galactify, or of course Wayra.
Cool. Thanks, guys. Bye-bye.
Okay, thanks. Bye.
Bye-bye.
Thank you. Bye.